You know, it doesn't matter whether you're working on a classic motor or if you're a racer constrained by the rules. Anytime you're working on a flat-tappet camshaft like this one, you have to take special precautions during the break-in process to make sure it's going to live. A flat-tappet camshaft has its own lubrication requirements because of the sliding friction created when the lifter rides up over the camshaft lobe. To combat sliding friction, motor oil manufacturers used to include a special package of additives known as ZDDP, or commonly referred to as zinc. But most modern engines no longer need these additives because they use roller lifters, and the zinc has been removed from almost all motor oils because it shortens the lifespan of oxygen sensors and catalytic converters. In addition to that, new, more aggressive camshaft designs have radical lobe profiles that raise the lifter faster and farther than ever before, and that can put an additional strain on the camshaft if you aren't careful. The result of not properly breaking in your camshaft is often a wiped or killed lobe, like you see here. Excessive friction between the lifter and the camshaft has actually ground off the nose of the lobe, and now that valve won't open fully. The first few minutes a new engine is run is critical to the life of a flat-tappet cam, but once it makes it through the break-in process and the lobes are properly mated to the lifters, you should be fine. The first step in breaking in your camshaft is to make sure you use the proper lubricants. For assembly, use a quality assembly lube that won't wipe off the cam easily. Comp Cams includes a pack of cam and lifter lube with its flat-tappet cams that's designed just for this application, and it works really well. You can also purchase it separately if you need to. For motor oil, a trick engine builders used to use was to pour oil formulated for diesel engines in their flat-tappet race engines because it had many of the same additives and could be bought in big quantities on the cheap. But recent changes to diesel emission rules means those oils are no longer a good resource. And because an oil manufacturer can change its formulation without any warning, your best bet is to always use an oil booster such as this break-in oil additive from Comp Cams. It's practically a must for breaking in a flat-tappet engine, but it's also safe to use with every oil change just to make sure your flat-tappet camshaft is protected. But there's more to it than just pouring in the right oil and then hitting the ignition. For more, we traveled to the shops of Keith Dorton's automotive specialists, where Dorton was putting together a late model stock engine. NASCAR late model stocks are a great example of the need to properly break in a flat-tappet camshaft. Plus, the tricks Keith has learned here will work with any engine. The cam being used is a custom grind Dorton worked with Comp Cams to develop. It has also been treated to Comp's Pro Plasma nitriding process, which actually injects nitrogen atoms into the iron of the camshaft. This makes the cam both harder and slicker to make it better able to withstand the incredible pressures developed between the lobes and the lifter when the engine is at speed. After making sure the cam is absolutely clean, Dorton coats it with a spray graphite lube. Spray graphite is also available in most auto parts stores for just a few bucks, and in addition to adding lubricity, it also gives the surface of the metal some texture, which assembly lube seems to stick to better. Then, both the lobes and the journals are coated with Comp's Pro Cam and Lifter Lube. That's all the prep that's needed on the camshaft before it can be installed as usual. Quality lifters cost a bit more than the imported pieces, but they're generally worth it. The tappet surface is more precise, and you can even get lifters like these that have an oiling hole which actually injects a film of oil between the tappet and the face of the lobe, virtually eliminating the old school process of grooving your lifter bores. And of course, the lifters are given a coat of graphite spray too before they're coated with the assembly lube and inserted into the bores. Once the engine is ready to be cranked for the first time, there are a few additional steps you should take. We're working with an engine on a dyno so you can see everything better, but the process is the same if the engine is installed in your car. First, if your valve spring's open pressure is more than 250 to 280 pounds, you'll need to knock that down a bit for the break-in, or you're virtually guaranteed you're going to damage a lobe. If you're using a nested double spring, removing the inner spring is a good way to do this. Or you can go with a set of low ratio break-in rocker arms to reduce the leverage the spring has on the lifter. Next, take the time to prime the oiling system by spinning the oil pump until you've filled all the oil galleries. You can buy a priming tool, or you can chop up an old distributor like Dorton has done here. Simply spin the oil pump until you have oil all the way to the rocker arms. Now, double check everything on the engine to make sure it cranks quickly. The last thing you want is to have the starter turning the engine over for a couple of minutes, because an electric starter won't spin the crank fast enough to keep the oil pressure up. So make sure your timing is right, everything on the ignition is hooked up correctly, and the carburetor is getting fuel. Once it fires, go ahead and bring the engine speed up to between 2,000 and 2,500 RPMs right away. You don't want to let the engine idle because the oil pressure won't be high enough for everything to break in smoothly. Run the engine for the next 30 minutes like this, while varying the RPMs occasionally between 2,000 and 2,500. Also, keep a close eye on your engine temps and oil pressure. After 30 minutes or so, the camshaft's lobe should be properly mated to the lifters. Shut the engine down, change the oil filter, and you should be good to go. But if for some reason you're concerned that you may have damaged a cam lobe, there is an easy test to find out so you don't have to tear the engine back down. Pull the valve cover and mark the push rod with a paint pen. Now, pull the coil wire or kill the ignition in some way and spin the engine over a few times. If the cam lobe has been damaged, it won't spin the lifter and push rod. But if the push rod you've marked spins like you see here, you'll know the cam lobe is still good. Now you can rest easy and go out and enjoy all that horsepower your new engine is making.